you can use the program mount. Mount is also the program that you actually use to mount one file system onto another, but if you specify mount with no command line options whatsoever, it simply shows you a list of all mounted file systems as follows. And we find that the root file system, which is the first line of this output, has actually come from a device file called /dev/sda1. /dev/sda1 is probably some kind of hard disk device, a block device as you might recall from the previous module. I'm not quite sure what the second one's all about, but the third one indicates that there's another hard disk, and that's mounted on /var. Then there's a third hard disk, /dev/sda6, mounted on /tmp, and a fourth one on /data. Again, I don't know what the fifth one's about. I don't know what none is all about. But the one after that, which says lilu:/var/spool/mail, means that on the machine called lilu, which is part of the same network, the directory structure under /var/spool/mail has actually been mounted onto this computer's /var/spool/mail. Which means, of course, that if you were to add a file, or remove a file, or modify a file under /var/spool/mail on this computer, then you would find that same file on the lilu computer in the same place. Finally, on the computer called bliss-hme1, there is a directory structure under /export/home, and that whole directory structure has been mounted onto this computer's empty directory called /home. We also get extra information about what type of file system it is and whether there's read-write access and so on. If it's a network device file, we are shown the IP address of the computer that the file system came from. So what I learned from reading this particular diagram is I know for a fact that all my files, which are in /home/mvirtue, are necessarily part of the /home file system, and /home has actually been mounted from the bliss-hme1 computer. So I find that even though I think I'm connected to this particular computer, well, I am connected to this particular computer, but the files that I'm accessing are actually coming from a different computer. They're coming from the bliss-hme1 computer. Some other useful commands when it comes to talking about disks is determining the available disk space or the used disk space on any given file system. You can use the df command for that. df is short for disk free. Let's have a look at it. I simply type in df and I get the following information. It shows me all of the file systems shown above, and it shows me how many 1 kilobyte blocks there are and how many have been used and how many are available. So if you, let's say, divide that number of blocks by 1,000, you'll get the number of megabytes. So in /dev/sda1 there's a total of 1,275,437 1K blocks, or approximately 1,200 megabytes or 1.2 gigabytes. And we also find that that is 57% used. And so on. You can read on down the list. And you can also find that /home is 98% full, which is quite interesting because this morning it was 97% full. So they're obviously filling that up quite quickly. I wonder what's going to happen when they run out of disk space. Interestingly, you can also use the df command with the -i option to determine the number of inodes that are used and available on each file system. You obviously don't get that information for network file systems because the network file system may actually be a subdirectory set. And what that tells you is that, for example, if you look at the data for the /var file system, that's used 58% of its disk space in blocks, but it's only used 4% of its inodes. And what you can infer from that is it's possible to run out of disk space before you run out of inodes, and it's actually even possible to run out of inodes and still have heaps of disk space left. I've seen that happen on some computers. Also, if you're talking about disk usage, you can run the du command, which is actually the disk usage command and find the total amount of disk space used by any particular subdirectory. That will give you information regarding that particular directory and all the files that it contains and all the subdirectories it contains and all the subdirectories that they contain, and so on and so on. It'll give you a total amount of disk usage, and it'll display it in 1 kilobyte blocks. Let's have a look at that. So here I am in my /home directory. If I just type in du, it actually gives me a listing of each of the subdirectories underneath my home directory and the number of 1 kilobyte blocks that each directory is taking up. And right at the bottom, next to the letter dot, it just gives me the grand total. Now, if I don't want to see all that intermediary information, I can just simply type in du -s of the directory that I want, or is it du minus lowercase s? There we are. So du minus lowercase s will simply tell you how many kilobytes the directory that you specify is using up. And by the way, that's also the number of blocks that are being used. Blocks are always the same size, and they vary in size from Unix to Unix. On this Unix they happen to be 1 kilobyte in size, but they're not always. On some Unixes they're less, maybe 512 bytes, and on some they're more, maybe 2 kilobytes. The number that you are given will always be the number of blocks, not the number of kilobytes. So you might have to do a little bit of multiplication or division to determine how many bytes or megabytes. From what I can see here, I'm taking up 77 megabytes on this system. I could of course do a du minus s of /, which would give me the number of blocks being taken up by the entire hard disk, or at least all of the file systems that are available, but it's probably easier if I just do the df command for that. If I tried to do du minus s of /, it would probably take a very long time to run. Incidentally, if you run the ls-l command in any given directory, you notice that the very first piece of information you're giving is something called total 157. That number, 157, is the total number of blocks taken up by all the files that you can see. So all the files represented below represent 157 blocks. Don't forget, of course, that the size of each block can vary from Unix to Unix. On this Unix, each block is 1 kilobyte, but on your Unix it might be half of that or twice that. So that's not necessarily the number of kilobytes. On this system, though, it is, so that's 157 kilobytes taken up by all the files in this directory.